So what we're going to look at now is we're going to look at the first part of the fundamental theorem of calculus. The fundamental theorem of calculus is a fundamental theorem, and so consequently it should tell you that it's pretty big. In fact, it's huge. It's the basis for calculus. We'll get more into like the theory of the fundamental theorem of calculus in class, but what I wanted to do is kind of show you what is the upshot of that fundamental theorem. So let's first take a look at the statement. If f is continuous on a to b, so that's our requirement. Okay, so f must be continuous. Then the function g, which is defined as g of x is the integral from a to the function x, right? So x is the independent variable, right? And we're defining the upper bound of the integral as x. So ax, f of t dt, okay, where a is less than or equal to x and less than or equal to b, is continuous also on a to b. So we get also that the integral is continuous and differentiable on a to b. And this is the really important part, that g prime of x, so the derivative of g, is f of x. So if you think about that, that's a huge statement. That's like a giant statement that says, you know what? What we know now is basically that the derivative of the integral is the function. Okay, that's exactly what it's saying. It's saying if I take a function, right, okay, that I know is the integral of some other function, its derivative is the function that we're defining the integral on. Okay, and it connects integral calculus to differentiable calculus, okay, or differentiation. So differentiation and integration are connected utilizing this fundamental theorem of calculus. So let's take a look at like what this means from a practical perspective. So let's say I want to find the derivative of g of x. So g of x, we're going to say, is equal to this integral from 0 to x of 1 plus t squared dt. What we're going to say is that f of x, or actually in this case f of x, or f of t, okay, is going to equal the square root of 1 plus t squared. Okay, so all we're going to do is define then that f of x is equal to the square root of 1 plus x squared. So using the fundamental theorem of calculus, what we get is that g prime of x is just simply going to be equal to the square root of 1 plus x squared. That's it. Right? I mean, like, it's super powerful, okay? And from a math perspective, it has a lot of meaning, but from a practical perspective, it's basically just saying, you know, this function is the derivative of this function. And that's all. So let's look at this one. Let's find the derivative of g of x. So g of x is equal to the integral from 0 to x to the fourth of cosine squared theta d theta. Now our first instinct is to say, okay, well, by the fundamental theorem of calculus, I should be able to say that g prime of x is just going to equal cosine squared x. But this isn't exactly true. And the reason why it isn't true is because the fundamental theorem of calculus, right, has it that we go from 0 to x of cosine squared theta d theta, and that would then give us that g prime of x would be cosine squared x. But that's not what we have. Instead, we're going up to x to the fourth. So what we're going to have to do is we're going to have to utilize the chain rule. Okay? So we're going to do a substitution. We're going to let u equal x to the fourth. Okay? And so that means that du dx is going to equal 4x cubed. Okay? 4x cubed dx. Or excuse me, it's just 4x cubed, right? Take the derivative of both sides. So now what we're going to do is we're now going to substitute. We're going to have the 0 to u is our integral, and then it'll still be cosine squared theta d theta. Okay? And we'll take d du of this function. Okay? So d du, and we're going to have to multiply that by du dx. And the reason why we do that is that du times du dx, okay, is just going to give us d dx. So it's going to be that derivative. But what it'll do is it'll help us to account for this u equals x to the fourth. It'll help us to account for the chain rule. Okay? So what I'm going to do now is I'm now going to take that derivative. I'm going to find this. So we know the derivative of cosine squared theta d theta is going to be cosine squared u, because we're taking it with respect to u, times, okay, 4x cubed, okay, because that's what du dx is. Then we just substitute in for our u, and so that gives me now cosine squared x to the fourth times 4x cubed. Or, more appropriately probably, 4x cubed cosine squared x to the fourth. Okay? So what we need to do here is we basically need to do the chain rule. What we're going to do is we'll take the derivative of cosine, the integral of cosine squared theta d theta, use that fundamental theorem of calculus, okay, to give us simply cosine squared u in this case, but then we're going to have to make sure that we multiply by the derivative of our upper bound here, which is x to the fourth. So let's take one more example. Let's say we want to find the derivative of y equals sine x to 1 of the square root of 1 plus t squared. Now, this looks a lot like the last one that we just did, where we actually had to make sure to use the chain rule, and we're going to do that again. But the other thing is that if we notice here, this is the fundamental theorem of calculus has a constant, call it a, going up to x of the square root, in this case, the square root of 1 plus t squared dt. Okay? Notice down here that our x value is actually at the lower bound, all right? And so in order to use the fundamental theorem of calculus, I'm going to have to make it into the upper bound. But if we remember our rules of integration, we're going to get that we can switch this around and make it negative. So if by switching the bounds, we make it negative, so we end up with sine x, or excuse me, not sine x, but 1 is our lower bound, sine x is our upper bound, and the square root of 1 plus t squared dt. And now we can do our integration basically using that chain rule again. Okay, so we'll let u equal sine x. So dx is going to end up equaling cosine x. Okay, so we take du of the negative integral from 1 to u now of the square root of 1 plus t squared dt times du dx. This gives me then negative, and this will just be the square root of 1 plus u squared. Okay, so that's our function, 1 plus t squared. We plug in the u for it, 1 plus u squared times cosine x, which equals negative cosine x square root of 1 plus, and now we resubstitute sine x squared, or sine squared x, whichever one you would use. And that is what the derivative is of this particular function of y. That's y prime. So the fundamental theorem of calculus is basically, it creates a connection between this integral and its derivative, all right? And for the purposes of, practical purposes as we're doing problems, what we really want to remember is we want to remember what the fundamental theorem of calculus actually looks like. It looks like this.